Hi, I'm Sean Gannon, and this is Minute Math. And today we're going to learn about differentiation and apply the chain rule and this one some product rule. We're differentiate each function with respect to x. So if I was given this function, y equals 5x to the third minus 3 to the fifth power times the fourth root of negative 4x to the fifth minus 3. Okay? Well, first thing, if you know my videos, I don't like seeing anything as a root. Okay, so in this case, fourth root, I'm going to rewrite that to be to the 1/4 power. So y equals 5x to the third minus 3 to the fifth power times parentheses negative 4x to the fifth minus 3 to the 1/4 power. Okay. Now from there, when I take my derivative, I need to apply the product rule. Okay. The product rule, okay, what we're going to do here is f prime times my g plus g prime times f. Okay, so if I take my dy dx here, okay, and I apply that little product rule going on, okay, and so we have f prime. I'm going to take a derivative of the first part here. So derivative of my first part is 5 times my parentheses, and we put it to the fourth power, and we keep the inside the same, 5x to the third minus 3. But then we need to multiply that by the derivative of the inside. All right, using the chain rule. So this here, derivative of that part, use the chain rule. And so I have, that's going to be 15x to the second power. Okay? And then we're going to times that by the second part, which is just negative 4x to the fifth minus 3 to the 1/4 power. Then we add that to the derivative of my second part right here, right? Derivative of that second part to be well, we're going to apply the chain rule again. 1/4 comes out, okay, times the inside 4x to the fifth minus 3, and we subtract that exponent by 1, which is a negative 3/4 power, okay, times the derivative of the inside of that parenthesis, which is a negative 20x to the fourth, okay. Then we take the last part multiplied by the end, the first parenthesis, 5x to the third minus 3 all to the fifth power. Okay, so now we're going to do some simplification. Okay, and when I do my simplification, and now you might have a little different, I know there's different ways to do the product rule. I basically, derivative of one times the other plus derivative of the other times the first, or the other one. And you know, it's just the first part. It really doesn't matter how you do it, it's still going to work out. Okay, so now I'm going to simplify this, and I'm not going to do much of a simplification. I mean, I can see that there's similar terms I might be able to pull out, but nothing's going to eliminate completely. So I'm just going to kind of keep it separated by two plus signs, left and right, and simplify within each one, and then we'll be done. So my dy dx here, okay. Well, my like terms, I'll bring everything together. 15 times by 5, 15 times 5, what is that, 5 times 10, 25, 75. So we have 75 right here. X squared. Then I'm just going to rewrite what's left. 5x to the third minus 3, all to the fourth power, times a negative 4x to the fifth minus 3 to the 1/4 power. Then we're going to add here, and this one I'm actually going to make into a fraction because I see a negative exponent. So I have a negative exponent right there. Okay, I'm going to bring that down. So I'm going to bring this first thing, I'm going to bring this exponent right here that's negative down to the denominator. So we have a negative 4x to the fifth minus 3 to the positive 3/4 power. Okay. Then let's see if I can simplify this in any way. I see the 4 and the 20, the 1/4 and the 20. I can cross them out and make that into a 5 or a negative 5 right there, right? Because 1/4 times 20 is a negative 5, or 1/4 times negative 20 is a negative 5. So I'm going to put that out front, negative 5x to the fourth times negative, sorry, not negative, we already brought this part down, just this part here, 5x to the third minus 3 to the fifth power. Okay. Now that negative, some people will rewrite this to be subtraction and bring that negative right there to subtract. We have plus and negative. Both are the same. 6 one way, half dozen another, it really doesn't matter. And at this point, I'm pretty much done with my simplification. You can simplify it probably a little more, maybe pulling some things out, some creative things. Does it really look that much nicer? Not too much, in my opinion. Your teacher might want you to do that, but I'm fine with the way it is. So our final answer is dy dx is equal to 75x squared times 5x to the third minus 3 to the fourth power times negative 4x to the fifth minus 3 to the 1/4 power plus, and a fraction here, like numerator, negative 5x to the fourth times 5x to the third minus 3 all to the fifth over this negative 4x to the fifth minus 3 to the positive 3/4 power. So let's recap. We're given a y equals, right, parentheses 5x to the third minus 3 to the fifth power times the fourth root of negative 4x to the fifth minus 3. I then rewrote that to be, instead of the fourth root, to be to the 1/3 power. At this point, I apply my calculus. I take the derivative, and I use the mix of the product rule and the chain rule. Okay, I took my derivative of the first and used the chain rule for that, times the second part, plus derivative of the second, using the chain rule, times the first part. After that, I just did basic simplification, okay? It's really up, but here is all the calculus. The rest is just simplification. It's really up to what your teacher wants. I'd be fine with this, personally, but anyway, my final answer would be dy dx is equal to 75x squared times 5x to the third minus 3 to the fourth power times negative 4x to the fifth minus 3 to the 1/4 power plus negative 5x to the fourth times 5x to the third minus 3 to the fifth power. All of that part, the second part, over negative 4x to the fifth minus 3 to the positive 3/4.